Hello there! This video is going to go over some of the most common probability or random sampling techniques, which are really the gold standard when it comes to external validity and generalizability of findings, or having confidence that your sample represents your population of interest. So I'll give you an overview and some examples of simple random sampling with and without replacement, systematic stratified random sampling, which is my personal favorite, and also cluster sampling. Then I'll give you an opportunity to think about it and answer some questions on your own. And then I will show you how sometimes we start off with the best of intentions and the most beautiful random sample, but in the end it turns into a convenient sample, which is what the next video will cover when we talk about convenient samples and non-probability sampling. So probability or random sampling requires access to a known population, which isn't really typical in social and behavioral sciences unless the population happens to be like employees at a specific organization or students at a specific school or patients at a specific clinic, right? If you're at a specific organization, it makes it a little bit easier. Probability or random sampling also gives you a calculable probability of selection. So you could just take 1 divided by the population size and know how likely it is that someone would be selected from that population to be in the sample. So that's why it's called probability sampling, because you can calculate the probability of a selection. Random sampling with replacement involves replacing the individual selected for the sample back into the population before the next sample member is drawn. And as you can imagine, this is pretty impractical in social sciences research. You do not want to study the same person twice or include one individual in multiple conditions of an experiment. Random sampling with replacement is really more relevant to things like Dungeons and Dragons, board games, and gambling. So you see my little D20 there to represent D&D. So with that, if you're rolling a D20, a 20-sided dice, you have a 1 in 20 or a 5% chance of a critical fail every time that the D20 dice is rolled. Despite the urges to think it's not going to happen again because it already happened today. It's random sampling and it has to be with replacement, right? Every time you roll the dice, you have a 5% or 1 in 20 chance of rolling a 1 and having a critical fail in your D&D game. Random sampling without replacement means that the probability of a selection changes with each selection because you are not selecting anyone twice, and the population gets smaller each time someone is selected from that population to be part of the sample because you're not replacing each individual before you make the next selection. This is kind of like bingo, right? There's only one of each letter or number combo available for selection, and each one can only be selected once. And once it's selected, it's not replaced back into the pool they draw from, it's just kept out. So, with each selection, the likelihood that one of your number and letter combinations will be called increases because the population is shrinking with each drawing. So check out the odds for the Powerball. There's a very predictable low probability to win any prize. To win any prize, it's a 1 in 24.9% or 1 in 24.9 chance or a 4% chance to win any prize. And you can see those any prizes are pretty small. Right? We've got $4 there. The odds of winning 50 grand, right, matching 4 balls and getting the Powerball, is 1 out of 913,129,000, which computes to a 0.000, wait, let me start to 4 zeros, 0.00001% chance of winning that 50K. So you can see it's almost impossible to win, and pretty much impossible to win the jackpot overall. The drawing involves random sampling without replacement. So each ball is drawn, and it's kept out of the population before the next drawing. So the entire drawing, right, is random sampling without replacement. But once the drawing's over, right, each individual drawing involves random sampling with replacement because your odds of winning with the same numbers does not increase over time because it's bound to hit eventually. Your odds of winning are the same every time regardless of which numbers you play. So random or probability sampling is not always easy to achieve, but random samples tend to lead to more representative samples than other strategies. And many of the analyses that are used to determine statistical significance are best for random samples. But there are statistical adjustments for probabilities and test statistics when you're analyzing data from non-probability samples. And those adjustments aren't really necessary or relevant in relatively small samples that make up less than 5% of the population. So we usually use the same statistical analyses regardless of the. So now allow me to show you some examples of probability sampling with a sample that is in Microsoft Excel. So we'll look at some examples here where the population equals the top 20 most famous people in the United States. You could see that list here from Jennifer Lopez to Beyonce. And this is going to demonstrate simple random sampling with replacement. So if you look at the formula bar right here, you'll see what this formula looks like. So you do equals, choose, and put a parentheses, and then type in rand between, or just double click it when it pops up. And then make sure that in your parentheses right here, that you put in the lowest score to the highest score. So I usually just go 1 and then to whatever my sample size is. In this case, my sample size is 20. Then you close it in a parenthesis, put a comma, and then hold down Control and click each individual cell of interest. And then you close out with the parenthesis and hit enter. And what it does is it gives you a random person from that list. And once you have that generated there, that random person from the list, you can just kind of highlight down. If you want a sample of 5, then you're going to go down so that you have 5 total rows, including the person that you just selected. And you're going to go to the Home tab, and then you're going to go to the Fill Down option and just fill it down. And it'll copy that formula down. And it'll give you, with replacement, a different selection. Notice here we've got 2 Lizzos, right? Because this is random sampling with replacement, it's possible to get the same person twice. It's drawing from that same population each time. So before it did the next selection, it chose somebody else. Notice also that Madonna kind of disappeared, right? So every time that you refresh this in Excel, it's going to give you a new list. So Madonna disappeared, but it copied the formula down and we ended up with our sample. So from there, be careful to write that down or to save it differently because again, every manipulation that you make is going to regenerate that sample list. So be careful. It makes it kind of nice if you need to get multiple samples, but it's kind of a pain if you're just trying to get one. So now let's take a look at an example using Excel to get a simple random sample without replacement. So we're going to be using the random number generator in Excel. So what you would start by doing is going into, I usually use kind of the column adjacent to my data. So we're still using our population of famous people. And you go in and you type in equals rand. And you can see that in my formula box here. So you'll type equals rand, hit enter. And then you will click that value you just computed and highlight down to the end of your data set. And then under the Home tab, you're going to go to the Fill feature and you're going to fill it down so that it goes all the way down. Then what I recommend you do is you highlight all those numbers and copy them. And then paste them as values so that every time you click something, the numbers do not change. Because again, every time you mess with something, those numbers are going to switch and you want to keep them constant. So you can copy them and then paste them as values. Then you want to sort them from smallest to largest or largest to smallest, whatever you like. And that option is also in the Home tab in Excel. And you can find this right here. That's where that little button lives. And you can sort those values so that you get them in order of that randomly generated number that it gave for each person. Always expand the selection so that the randomly generated number stays attached to the person it was originally attached to, even when you sort by that number. Then you'll see that you have people listed in order of their randomly generated number. And you can just grab your sample from that list. So if your sample size is 5, you can just grab the first 5 people, and that's your sample. Now let's take a look at my personal favorite in terms of sampling strategies, stratified random sampling. So strata is just another word for homogeneous or similar groups. And with stratified random sampling, you do random sampling within multiple homogeneous groups or strata. And the hope is that you are going to not leave representation to chance, right? You are going to strategically sample from these groups to make sure that you either have equal representation or representation that represents the population within your sample. You really have to have some variable of interest in mind, though. So you're going to separate the population into non-overlapping groups or strata based on some variable of interest, like college major or ethnicity or first-gen college student status or sex. Then you have to decide how many individuals will be sampled from each strata or each similar homogeneous group. If you do a stratified random sample, then you just make sure that you have an equal number of members from each group in your sample. And that may make sense. If you're running an ANOVA, it's nice to have the same number of people in each group. So from an analytical standpoint, it can be an advantage. But in most cases, it's better to have a proportionate stratified random sample, which is where the number sampled from each strata or homogeneous group reflects the relative size of each group in the population of interest. So as you can see here, if 50% of the population is red and 25% is blue and 25% of the population is green, then you want the sample to represent that. So in a sample of 4, you would randomly select 2, 50% from the red group, and 1 or 25% from the blue group and the green group to have a proportionate stratified random sample. Then you just randomly select the determined number of individuals from each group and combine the sample and start your research. This is a strategic sampling strategy that ensures that all groups of interest, even the small ones, like the Gen Zs and the professor example earlier, are included in the sample without just relying on chance and a huge sample to improve the chances of having a representative sample. So researchers typically use stratified random sampling when some sort of grouping variable may have an impact on the results of their study and when these groups within the population are small. So for instance, if you wanted to examine the differences in awareness and understanding of graduate school programs based on whether or not a student is a first-generation college student, and you're doing this research at a university with only 20% first-gen, then you need to strategically sample from first-gen students to make sure that they are included. So stratified random sampling is a great strategy, but it requires access to the population and prior knowledge of how grouping may have an impact on results. So it can be difficult, and it is somewhat rare in human subjects research, even though it's my favorite. So now allow me to give you a practical example of what stratified random sampling would look like in Microsoft Excel. So what you start off with is your population. And then in addition to having the people in your population listed, you need to also have a variable next to it that reflects and represents the variable that you're going to use as the basis of your stratified sampling. So what type of homogeneous groups or strata are you looking at? In this example, we're separating our famous folks based on sex, female or male. So you see that data there. So the first thing that you need to do is you need to sort your data based on that grouping variable. So in the Home tab, you highlight your data, right? Don't highlight the title, but highlight the actual data, not the variable name. Go to the Home tab, go to your sort feature here, and then you sort A to Z or Z to A, whichever you prefer. And what that'll do, make sure you expand the selection, right? So make sure that you expand it so that Jennifer Lopez is still a female and Johnny Depp's still a male, right? Those variables stick with their original person, and then hit sort. And now you'll see that the data is listed in order of that grouping variable. So all the females are first and all the males are listed second. Now you can separate those two groups, the males and the females, and use the random number generator, that equals rand feature that I showed you earlier, to create random numbers. And then you want to sort them, like I showed you earlier for those random samples without replacement. You want to sort those based on highest to lowest or lowest to highest. So if your sample size was 10 and you were doing a stratified random sample, you would want 50% of your sample members to be male and 50% of your sample members to be female. So that would be 5 of each if you were doing a traditional stratified random sample. And it's a random sample, remember, because you ordered them based on those random numbers. As you can see, our population, everybody listed here, has a distribution where 60% of these famous people are female and 40% of these famous people in the population are male. So if we were doing a proportional stratified random sample, this would reflect that. And so we would have 60% or 6 out of 10 females and 40% or 4 out of 10 males in our sample. My second favorite type of probability sampling, just because I use it a lot, is cluster probability sampling. And it is somewhat common in organizational and institutional research settings, which is where I do most of my work, where individuals are nested in departments, classes, clinics, or any other pre-existing group. So instead of randomly selecting individuals, the researcher randomly selects groups or clusters of individuals. So for example, let's say that I was doing a proportional random stratified sample of 6 professors, and 3 were male and 3 were female. And that sample, that stratified proportional random sample of professors, they're going to use Blackboard Ultra for a semester and compare student satisfaction with their learning management system to the population of students being taught by the other faculty who are still using Blackboard Learn. So while the professors were randomly selected, right, half male, half female, randomly selected, the real sample here isn't the professors. The real sample is the students. And the students are in clusters or pre-existing groups and are not randomly selected individually. But there's still a computable probability that your class, your cluster, would be selected. So it's still a probability sample. So cluster sampling does run the risk of poor representation due to the characteristics that clusters may have in common that differ from others. But there are statistical techniques like hierarchical linear modeling that can be used to see if cluster membership had an impact on your results. So looking at, how much of the observed differences in student satisfaction with their learning management system is predicted by the type of Blackboard being used, Ultra versus Learn, versus their professor. So there are ways to statistically control for kind of the nested nature of this data. Now I want you to practice to see how much you retained from this video. So take a look here at this example and try to figure out which sampling technique is being used, and think also about how the strategy could be improved. So pause this video and take a moment to think about this on your own. Okay, so hopefully you tried this on your own. And now I want to just go over the answers for you. So you can see here that the LGBTQ+ office at Marshall University is looking at surveys and focus groups to study student attitudes and perceptions about the campus resources for that community. So they get a random list from the registrar of 75 MU student emails, and they send 3 recruitment emails to the list of randomly selected students, and they get a 65% participation rate. So with this sampling strategy, it started out as random without replacement, right? There was a random list of 75 students. However, it's not really that anymore. It's now more of a convenient sample, which you'll learn about in the next video, because we only have 65% representation of that random sample, right? And if we think about that also, this sample of 75 students is supposed to be a proxy for 13,000 students at Marshall, right? And that's only 5.7% of the population. So how could we improve this strategy? Well, one way, of course, is to up the sample size, right? We want to have a larger sample so we can be more confident that that sample reflects what all the other students feel like at Marshall. And it would also be nice, because this is specific to the LGBTQ+ community, and they're a relatively small group on campus, to also do a stratified sample to include students in the LGBTQ+ community. In this case, because they're a relatively small group and we care quite a bit about how they feel, I would probably go with the equal proportion stratified random sampling and just try to have half that are and maybe half that do not identify as LGBTQ+. So I want to end this video by reminding you that even if we start with a random sample, typically that sampling technique is going to shift, because in behavioral and social sciences research, our population of interest is typically people. And when you're studying people, ethically, if you remember from ethics, you have to rely on voluntary research participation. You can't force people to do it. So you may start off with your having access to your population, then you take a random sample or a sampling frame from that population. But a lot of times in human subjects research, your sample doesn't include everybody from your sampling frame that was so beautifully and randomly constructed. So you usually do end up with a convenient sample of subjects, which doesn't lend itself as well to external validity and being confident that your findings represent everybody that you're interested in. So I hope you enjoyed learning about probability samples and nerding out with Excel a little bit with me. And you not only feel more prepared to do your own research, but also to evaluate the merits of the research that are conducted by others.